Yeah, today I'm going to talk about functions in Kotlin. And so I really love functions. I love Kotlin in general. And so I think functions are an interesting look into what's like to learn Kotlin because it's so easy to get started. There's lots of really useful things about them. But as you start to dig in further, you can find more and more interesting things. And really, it all adds up to a very delightful developer experience, which is largely why so many people have enjoyed using Kotlin. So some of these things are, we have free functions. We don't have to have necessarily all the helper methods or these classes that have nothing but static methods on them, which is nice. We have things like higher order functions, which are incredibly useful, and we see lots of examples of that in the standard library. And then finally, we do have this very rich set of functions in the standard library that make our lives much easier. Some of those examples are things like array of or list of, which are very small, might seem trivial, but also very convenient to have. More useful, interesting things like measure time in millis, where we can pass in some piece of work and measure how long that takes, which is really awesome. Or empty is another really convenient one, where if you have a collection or a string and you don't want to deal with null, you can call or empty and pass a nice convenient empty string or empty list instead. So there's lots of things that we can leverage that add up to a really nice experience. And so today I want to look at that and kind of explore together how to go from the very basics, how to start, kind of bridge the gap from Java methods we're comfortable with over into simple Kotlin functions. Then we're going to look at how functions are flexible, how they're convenient, and finally a little bit at the end of how all of that adds up to letting us kind of rethink how we write our code, how simple it can be, how concise, and again, look at that nice, delightful experience. So Kotlin is easy to get started. Well, what does that really mean? Well, there's a number of options there. The most simple, probably, if you're an Android developer, is to invoke the convert Java class to Kotlin and just see what that code looks like. So if you haven't really worked with Kotlin yet, this is a great way to see what your methods would look like once converted to functions. There's also the Kotlin cones online, or the REPL tool within IntelliJ or Android Studio. And so you can start to use all of those and see how you can transfer existing knowledge over to Kotlin. So that's what we're going to do now. So here we have a simple class greeter with a very simple Java method, hello functions, that prints out something. And so we'll notice here we have our return type, we have the name, and we have a method body. Pretty standard, probably no surprises here. If we then convert that to Kotlin, we might end up with something pretty much like this. And so here we notice it looks basically the same, but there are some small differences. So we have the fun keyword now, indicating that this is a function. We've lost the return type, which might seem a little disconcerting at first, but don't worry, bear with me. And that's kind of it. Everything else is basically the same. But we can actually simplify this even further if we want. Because there is no return type here, we can actually define this as a single expression function. Find it all in the single line there and just omit that block body and have a nice concise way of expressing this function. And if we want to go even further, if we don't actually need that class, we could make this a top level function, meaning that it's not scoped to any class or object. And so we see right here where just that simple conversion, we can actually start to do multiple things with this that in certain situations can make our lives much nicer. So now let's start looking at some of the ways that Kotlin functions are flexible and convenient for our use cases. We're going to look at things like parameter and type flexibility and what we can do with those. Different variations in scoping. Where do we define these? Where can we access them from? And then finally, some different modifiers or some different types of functions that might change how we interact with them or the performance characteristics. So parameter and type freedom. We have a number of things that we're going to go over quickly here. We have default parameters, named arguments, variable number of arguments, inferred return types, and generic functions. And you'll see a lot of these in the standard library. You can use them in their own code, and they do a lot for us. So let's start with the basics first, though. In Kotlin, of course, you can have parameters to your functions. If you could not, this would be an awkwardly short talk. So here we have a parameter called exciting thing, and it is of type string. Now, one thing to notice here is that the name comes first, then the colon, and then the type. So it's reversed from the Java world. And we invoke this, as we might expect. We pass in our string literal. Everything is happy. We say yay functions. And then obviously, we can have multiple parameters. So again, we do this just like Java, where we separate them with a comma. And then again, we invoke this just the same. No surprises here. So now we can get into the interesting stuff. Default parameters. So now if we look at exciting thing here, we notice that it has this extra bit of syntax to the definition where after the type, we then say equals, and then we're giving it a string literal of functions. So what this is doing is actually defining what the default is if that argument is omitted when it's called. So here if we invoke hello functions and we pass in 2 strings, we'll output yay functions as before. However, now in the second example, if we just pass yay and nothing else, we'll actually get the same output. And that's because if function parameters are omitted, then we can use that default value. This allows us the flexibility of having overloads without the verbosity of having to define every single one. So you can have your single function with all of these parameters that you might need in certain situations, and then you can apply the defaults to those. It also allows you to define what the sensible defaults might be. So you don't have to guess as to whether you need an empty string for a default or some arbitrary other value, or whether null is acceptable in this case, or maybe an empty object. You can actually build that into the signature of the function, and it helps to self-document the code. Now, unfortunately, with a lot of this stuff, the Java interop story is a little bit different. So Java does not have default parameter values, as we probably all expect. So you must specify all the parameters when calling the function. So you can't omit them. So here in this case, if we call hello functions with both parameters from Java, that will work fine. However, in the second example, it will not compile because it doesn't know where to find this method with just a single argument being passed in. However, we can get around this if you really want to. If you're working very much between Java and Kotlin, you can add the JVM overloads annotation to your function. This will then generate the overloads for you so you can use it consistently in both languages. So if we add that annotation to the same function we had before, we'll then get some generated code like this in Java. So we now have multiple methods that have been generated, and it will use that default value where needed. So now if we go back and look at our invocation again, we see both versions of this now work from Java as well as from Kotlin. Named arguments. So let's look at this hello functions invocation again. We see functions. Maybe this is in a code review, and we might instinctively know that this is wrong because why are we passing the same thing in twice? But just from looking at this, you don't know which is correct. So you probably have to open it up, go look at the documentation, see which is correct. But we can do better than this with Kotlin and named arguments. We can invoke our function like this, where we actually give the name before assigning the value to that argument. So in this case, we can see that we're going to use yay as the exclamation and functions as our exciting thing. This is much more self-documenting and easier to understand what's going on here. Helps improve the readability of the code. We can also modify the order when using named parameters. So we don't have to assign them and pass them in the order in which they're defined in the function signature. This is really useful if you are refactoring things, because if you want to change the order of something, add a new parameter at the beginning, it doesn't throw off everything else, assuming that you have the named parameter syntax being used. Works also really nicely with default values. So here again, we have our hello functions with our default value. We can pass in 2 strings, and it'll work fine. We can pass in a single string, and it'll work fine and use the default for the second parameter. Or we can define 2 in reversed order, and because we're using the named parameter syntax, everything works nicely. So this is really convenient for us, and it lets us worry about leveraging the functions we know are there and not getting bogged down on the syntax or the ordering. Lets us move on with our day. So, and again, there are limitations to this. You can't interchange them in a way that confuses the compiler. So what does this look like? So again, in the first example, specifying both, it knows what to do with that. The second example, again, we pass in the one, and then we use the named syntax for the second argument. Again, it knows how to handle that. However, in this case, if we first specify the second parameter, which is exciting thing, and then we don't use a named parameter for the next one, that will confuse it. It doesn't know how to handle that, and so we will get this error saying mixing named and positioned arguments not allowed, which is at least nice because we can go back and quickly fix this. So if you're going to use the named, it's often nice to just use it for everything consistently, or use the named ones for parameters at the end of your signature. And again, named arguments not supported from Java, probably no surprise there, and you must pass them in the order in which they were defined. Variable arguments. Now this is something that we have in Java as well, and it's largely similar here. So we can define a parameter to accept a variable number of arguments of type t. That is done by using the var arg keyword, and that parameter will then be treated as an array of type t. This also means that if you're using a default value, the default value must now also be an array of type t. So here, maybe we have too much excitement for a single parameter, so we want to pass in multiple exciting things to print out. So we can see our function now has been updated to iterate over that array of strings and print out each line. So here we can say yay, and we pass in multiple strings. It will treat those as an array of strings and then iterate and print out the 3 lines of output there. Now, typically, the var arg will be the last one because it just makes sense to sort of specify that unbounded list towards the end. However, it doesn't have to be. So if you're using named argument syntax, it can, in some situations, figure out how to handle that. Or if the last param is a function passed outside of the parentheses, which is kind of a separate thing that we'll take a look at later. So again, in this case, if we pass in yay, multiple strings, it knows how to handle that. It takes the first one as the first argument, the rest become part of the var arg. In the second case here, again, we're using named syntax for yay, so then it will assign the rest to the var arg again, and we get the same output here. However, in this case, this works, but it might not be what we're expecting. Because there's no default for the first parameter there, it's then going to use Android Summit as the exclamation, and then iterate twice for the var arg. And then in this case, it won't know how to handle this. Because we're using the exclamation in the middle, it then splits up the rest, and it doesn't know how to treat that as a single input array, and so we get a compiler error. This is also useful if you have an existing array and want to immediately pass that into a function in a concise way, or maybe add to that. So if we define an array of things to be excited about, we can pass that into this function by using the spread operator, which is defined by the asterisk sign there. So this will tell it to use that array, essentially spread the values, turn that into that input array, and we get this. And we can mix those as well. So in this case, we'll pass in our exclamation again, and then we're going to mix in our own new exciting thing plus the input. And in both cases, this will work, but the ordering does matter. So in one case, you'll get coffee first and then the other things, and in the second case, that will be reversed. So we have flexibility to take in things, mix those, and all pass them in through a single function. Return types. We saw this a little bit at the beginning, where we kind of lost our return type when we converted from Java. So again, this is a similar function here. What is the return type here? We don't have it defined. Well, if the function doesn't return any useful type, like in this case where we're just printing something out, then the return type is unit. So these are equivalent here. We have one that explicitly says it's going to return unit, which, because it's unit, that means nothing useful. It doesn't have to have an explicit return. In the second case, because of that fact, we can just omit it altogether. However, if you are going to return something specific, in this case string, then you do have to have the return statement if you're defining this with a function body. So if you're going to have the curly braces there, you have to have that return. However, if we go back to the single expression functions that we saw before, if you can define this as a single expression and that return type can be inferred, then you can omit the return type. So in this case, we're concatenating two strings, so it knows that that output is going to be a string, and we can define this in a single expression and omit the braces, omit the return type, and have a nice single definition of what this function looks like. Generic functions. Again, we had generics in Java, and likewise, we have generic functions in Kotlin. Many of the classes in the standard library are actually built on generics, so we get the nice, same useful functionality across all of our types. And here's just a couple examples of that actually taken from the standard library. So you can see, define them very similarly, specify the type, and then define the rest of the function implementation in regards to that type, and now you can use this all over the place. So things like filter on iterables, use that all the time, or something like the scoping functions like let, apply, also are all based on these generics. Variations in scope now. So where do we define these functions, and how does that impact how we then consume them? Well, we have a number of options here. We have top-level functions, member functions and methods. You have local functions or functions on a companion object or extension functions, which a lot of people are excited about. So top-level functions, these are functions that are not associated with a class or object. These are defined somewhat globally in a Kotlin file and belong to the package of that declared file. So if you want to then use this function from your Kotlin code, you can import the function and start using it without any type of class or object having to be present. So this is really great then for replacing things like helper or utility classes. Classes that existed solely to house static methods that operated on some common data type. We can now turn these into top-level functions and have them globally available to us. Now, this sounds great, and from Kotlin, it is really convenient to use, but we're not actually getting away from classes altogether. Underneath the hood, there are still classes generated into Java, and those are done using this very specific syntax, which is the name of the file with a KT at the end, .java. So to help see what that looks like, we have a file here called logging.kt. Then we have, it's in package logging, and we have our function log. Now from the generated code, that's what this then looks like. Again, the name of the file was logging.kt, so the class becomes logging.kt, and then the function becomes a public static void, and then the rest is the same. So if we then want to consume this, from Kotlin, we just call log, and it's very convenient. From Java, it's a little less convenient. We have to reference that class. So we have logging.kt.log. So it becomes the regular static invocation that we're used to from Java. Now we can actually improve this a little bit if we have to worry about this interop story. You can override that generated class name by using the @file JVM name, and then you pass in the name that you want to switch it to. And this must be done before the package declaration in the file. So again, we go back to our file logging.kt. Now we add that annotation, and we say we want to name this generated class logging functions. And then the definition of the function stays the same. Now when we call this from Kotlin, nothing has changed, looks exactly the same. But from Java, we now can say logging functions.log. So this is a little bit nicer. If you want to clean up what that looks like from Java, you have the freedom to choose what that looks like and make it fit into your team or your code base's coding standards. Member functions, function associated with a class or object. So this operates just like in Java with our methods. They have access to private members of that class or object. So we can define a class speaker, function give talk here. We can create an instance of the class and call that method on the function. Nothing's really changed there. However, there are, again, a couple considerations when talking about Java interop here. Default arguments can't be changed in overridden methods. And if you have the default values in the base class, you have to just omit them when overriding that altogether. So that's one thing to be aware of if you're going to be providing defaults in your base class. Local functions. So this gets maybe a little bit weird at first, coming from the Java world. We can have functions inside of other functions. And that function basically lives within the scope of that function itself. And this can be really useful if you want to clean up code that is maybe only used from within a single spot. So you could, instead of creating separate private methods, for example, you could create local functions to still reuse and to clean up bits of code, but keep them scoped within the function that's using them. These are also useful because they then have access to all of the parameters of the enclosing function. So again, it's a convenient way of cleaning up logic without having to add a bunch of methods necessarily to your class that then might start to get creeped in and used in other places where maybe they weren't originally intended. So this is what it looks like. We have outer function. We take an argument name. We then define inner function to print name. Because it has access to the same variables of the outer function, we don't have to pass that into inner function. It just has that reference, and when we call inner function, it'll print out that passed name. So this is a very simple example. Let's look at a little bit more detail why we want this. Like I said, it can help clean up your code. It can help extract useful bits of common functionality within a single scope. And it can help avoid deep chains of function calls. So sometimes when you start refactoring something to pull out common pieces, you end up having to click into an implementation and then click into something else and click into something else. And pretty soon it's hard to keep track of where you actually are in this call stack and where sort of the origin point was. So with local functions, you can keep this scoped to that single function if you would like. So in this example, we're doing some parsing of this response. And we have multiple places that are pulling out a key using the same syntax. So we could create then a local function called parseKey, which knows how to pull that field out and then reuse that below. And if that parseKey is only relevant in this scope, then there's not necessarily a need to pull that outside of this, and a local function might not be a bad option. So when should you use this? When should you not use this? That's actually really good questions because you can misuse it. It's very easy to make everything a local function and not be able to understand the class anymore. If you make a local function, you can't test that function in isolation. So if that's a concern, then you'll probably want to pull that out into something not local. And finally, just is the enclosing function still readable? You could put so many functions in there that it's hard to tell what's really going on. So something here that can be very useful, but use it wisely. Companion objects. So like we've talked about a little bit, Kotlin doesn't have any true static method or function calls here. And kind of the default recommendation if you're reading, say, Kotlin in action, is to use top-level functions instead. However, there's still use cases where this might not be what we want. And a good example of that could be if you want to create, let's say, a factory because you want access to private members or constructors. So in this case, we'll have a class course, and we'll define a private constructor here. So if we wanted to then create a top-level function to create that course, we might do it like this, but it wouldn't compile because the constructor is private and the top-level function doesn't have access to it. So we could change this to create a companion object. It now has access to the private constructor, and we can create our course, and then we can call course.createCourse, and we have our nice factory from Kotlin. Now, another example of this, maybe more relevant to us, is let's say we want to create a fragment and we want to have a new instance here. So again, we'll do the same thing, create our companion object, new instance. However, from Java, this is kind of ugly. We have to say authFragment.companion.new instance. So we have to explicitly reference the name of that companion object, which is not the greatest. However, thankfully, there's a couple things we can do to make this better. One thing is that we could actually rename that companion. So maybe companion doesn't give you a lot of information. There's no like semantic meaning behind that. You could change that to something like factory. So now the invocation of this is a little bit more clear. We could say factory, not new instance. So maybe you're going to have multiple factory methods on here. This now doesn't look quite so crazy. However, if we want to get rid of that companion altogether, we can use the JVM static annotation, which will actually, underneath the hood, generate a true Java static method for us to use. And then we can avoid companion or factory or anything else and just call the function directly. Okay, variations in functions. We have a number of options we're going to cover quickly here. So infix functions, extension, higher order, inline functions. And these, again, crop up a lot in the standard library, and they're really interesting and allow us to do some pretty cool things that can make our lives better. So infix functions. Infix keyword enables the usage of infix notation. And if you're then thinking, what is infix notation? That's a great question. I wasn't entirely sure when I first read that. So essentially that means that you can omit the dot and the parentheses from your function call, which sounds kind of weird and honestly looks weird. So if you see key to value, that is actually an infix function, and that would be equivalent to saying key dot to parentheses value. The nice thing about this is it can actually be very human readable to do infix functions like this. So to start, we have to be a member function or an extension function, and you have to take a single non-var arg parameter with no default value, which is a mouthful. There's a lot of restrictions here, but they make sense. Because if you're going to use something that looks like key to value, and you start trying to omit things from that or pass multiple things in, it's not crazy to think that the compiler doesn't know how to handle that. So they place the restrictions on us. So here we define a class called conference attendee, and we have a function called addInterest, takes a string. So we can do that in kind of the normal way that we're familiar with, attendee.addInterest, pass in our interest, or we could use infix notation, which is attendee, addInterest, Kotlin. So that's really nice. It's very human readable. It's easy to kind of understand semantically what's going on. And we can achieve that by simply adding that infix keyword to the function definition. And so infix is really convenient if you're thinking about building DSLs, for example. It's also built into the standard library. So in this top example here, we have for I in 0 until 10. Until then is a infix function that provides us an int range. And then step is another infix function that tells us how to step over that range. So I in 0 until 10 step 2, it reads much nicer than it would using the parentheses and dot syntax that we're used to. Again, another example of 2 right here, where we can create a pair of the one value with the other. Or we could do them for things like logical operations. So reading things like true or false, true and false. Again, those read much nicer and they match how we are logically thinking about these things. So there's lots of nice little ways we can start to integrate those into our code. One really nice example of that is the Kotlin test here. And so you see we have infix notation, or infix functions here that allow us to write tests that just make sense. So saying hello should have substring, it's very clear there to see what is being tested and what should be correct. Again, hello should not have substring, also very clear to understand that. So if you have this type of logic in your app and you want to be able to write it in such a way that's very easy to understand and reason about, you might be able to get that with infix functions. Extension functions. This is very popular because it allows us to extend existing functionality, especially in classes that we maybe don't own and want to use in a more convenient way. Also very useful, again, for removing helper classes. If you have a whole set of functions that are all utilities around context, for say, you could define extension functions for those instead, and so you can call them directly on a context from Kotlin, which looks much more natural. So here's an example where maybe we want to check whether a view is visible or not. We could define an extension function for this, and so now we have view is visible, This looks very nice. It looks like a natural part of our API, and we could go about extending things further if we wanted in this way. Again, here's another example. Perhaps we want to have a function for showing a toast. So this could be a top-level function, takes into context the stuff we need to make this, and we might call this like this. Show toast, pass in the context, the message. That's pretty clean, maybe a little bit nicer than what we're used to. However, we could convert this to an extension function. So now instead of passing in a context, we make this a function extending from the context there. And so now our syntax looks like this. We have context.showToast. So this looks even more natural, and it feels like a regular part of the API. So again, if you see this, you might be thinking, like, how does this actually work? What's the interop story here from Java? Well, again, we have generated Java under the hood for us. And again, these are static methods, and they will take the receiver as the first argument. So in the previous example, the context is the receiver, and so our static method will have a context as the first argument. And the format for the generation is, again, the file name with KT, and then the name of the function. So if we look at this for our context, we see that we have the show toast, and it takes in the context as the first thing, and then the rest of the parameters. So from Java, we can call it as context extensions kt.showToast. And like we saw before, you could change the name of that generated class into something like context helpers if you wanted. Higher order functions. This is one of the really cool things about Kotlin. You can return functions from a function, pass functions to each other, and you can do a lot of cool things with this. This is how a lot of the standard library works. So the functions that you pass in, they could be a lambda, which we're probably starting to become quite familiar with, or it can be a function reference. So this is nice if you want to define a function that's maybe used in multiple places and also pass that into another function, you can pass that function reference directly. So one of the nice things about this is it does support a more functional programming paradigm. So we see this in things like for each, filter, map, where we start chaining functions together, passing in functions for a predicate to determine what the outputs of this are going to be. You can also use it to start to clean up common use cases, such as shared preferences, where you have a consistent setup, do something, tear down, or shared preferences kind of the same way. So here's an example of a function that actually returns some other functions. So we might imagine we're passing in a difficulty level for a game, and we want to get a reference to how we should calculate scores for this. So this will return a function, and then we could hold on to that function and actually call it in other places. Here's another example where we are defining a function, in this case called predicate, that takes in a number and basically returns a Boolean determining if that number is greater than 5. We can then define a list and pass that predicate in, and this will filter based on that criteria of the number being greater than 5. So here, again, we could do the same thing. We've now defined a single expression function, which does that same thing, filter, and we can pass a method or a function reference in instead. And again, this is one of the really nice syntactic sugars that Kotlin provides us. If we have a function where the last parameter is a function, we can move it outside the parentheses and just define it like this, sort of in the lambda syntax. And so this is, again, we see all over the place in the standard library because it makes for nice fluid APIs that are sort of easy to write, easy to read. So here's one more example that we're going to kind of build on here. So we have a synchronized function, and we do some setup. Then we're going to invoke the function that's passed in to do some work. Then we're going to do some teardown. So if we look at that down below, we call synchronized. We pass in the lock. The function then is passed outside of the parentheses, so we don't have multiple things inside the parentheses, which is nice. However, higher order functions do come with potential runtime penalties. So we have extra classes created when using the lambda. And so if the lambda is capturing variables, you get extra objects created on each call. This is particularly a concern if you're going to be iterating over a large collection, perhaps doing many operations on that, and you might end up creating objects for each of those that are capturing more and more state. Thankfully, we can use inline functions to mitigate this. So this helps solve that specific problem. And basically what it does is it takes the body of the inline function and just substitutes that in for the invocation of that. So what does that look like? So here we have another version kind of that same code. So we have a lock, we do the action unlock, we call it down below, same as before. If we then call this, we're going to say inline example, print line, we're going to call that synchronized function. What it's going to do is print out the action, and we're going to do print after. So this looks nice. This is how it would look if we were writing the code. But because the synchronized function is now inline, under the hood, this is essentially what gets generated. So where we had the function call of synchronized, it now is replaced by the implementation of that. And so this is how they avoid the runtime hit, because the code is just right in line there. It doesn't have to do all that capturing, doesn't have to create the object. So we've gone through all of that. We've seen a lot of the ways that this is convenient, how it's flexible, lets us do some cool things, like why does this matter for us as Android developers? And I think that because of all this flexibility, it kind of lets us reimagine how we think about building our apps. So we've seen a couple examples already. You can replace things like view utils, context utils. You can have extension functions for that, top-level functions for that. You don't have to have these extra classes. Less boilerplate. So again, things like the shared preferences, or something like this, for example, if you have some code that is unsafe, maybe throws an exception, you want to always make sure you're catching that so you can continue about your day. You maybe don't want to wrap everything in a try-catch. Well, you could do something like this, where do the thing safely, pass in the work that you care about, and now you don't have to bother with that try-catch, any setup or teardown. It just makes your life a little bit easier. Again, we can use things like extension functions, top-level functions, default parameters, all this to clean up APIs we have. So maybe there's a set of functions that we commonly use, but they're not the most convenient. We wish they worked in a different way. We can kind of write our own wrappers around these to allow us to work with them the way that makes the most sense to us, to our team, to our projects. And so we're actually seeing examples of this now. We're seeing things like Android KTX, Anko, there's the Arrow library for functional programming. And those are really solving these problems. They're enabling people new APIs, basically, to make our lives easier. So from KTX, we have a couple examples. Shared preferences. Instead of having to always do the whole edit, do some stuff, commit or apply, we can simplify that song and dance a bit by saying preferences edit, pass in a function that takes the transaction as the receiver, and then we can make our modifications to that. So we don't have to worry about the setup and teardown. Fragment transactions, the same thing. We can say, do a transaction, define the steps we want to take, and we don't have to worry about the begin transaction, commit transaction. Cleaner syntax. Things like logging, running something on a background thread. You could create your own functions for these and kind of develop your own version of what your standard library looks like, your own kind of DSL to call things that feel very natural, fluent, and look like first-class citizens. This can also simplify, testing, for example, if you have this common set of things, and you can change the implementation without necessarily always having to mock out the class, possibly. You can pass in a different function. You can avoid the extra classes, which is nice. And then finally, like I've mentioned, we have a whole slew of classes in the standard library, or excuse me, a whole set of functions in the standard library that are really awesome. So I talked about or empty already. Things like array of, list of, map of, make things easy. Functions like associate by or group by that let us manipulate our collections are incredibly useful. If we're doing operations on a set, we can map them, or map indexed, which lets us avoid cumbersome looping and managing indexes, or things like reduce, sum, allowing us to calculate or perform operations on these large sets in a very easy, fluent way. So here's just a couple examples of that. Maybe you have a list of download records and you want to calculate the total size of that very easily. Instead of iterating over every item and manually performing that calculation, you could call SumBy and pass in a function that says this is the value to SumBy, and under the hood, it will do all that summation for you. Very convenient. You could do sorting, same way, very simple way to sort, and it's nice and fluent. We're not delegating to any type of static helper, just nice first-class support for this. A couple more here. Group by. This was really useful for me recently. Say you have a whole set of download records, and they maybe have multiple keys. You could use group by and pass in, let's say, the enrollment key of each download, and it will return you a map of that enrollment key and every record that matches that. So now you can quickly parse out all that data and know like which ones are related to each other. And you can actually then combine this with things like associate by and filtering and do a lot of complex operations very quickly. And then in the last example here, we're kind of combining a couple of these. Say we get some input records, maybe coming from the Java side of our code base, maybe from a network request where we can't guarantee this is going to be non-null. We could use that or empty function that I talked about, which will say, give me this list or collection, or give me an empty collection. We can then call map, pass in a function on how to map this, say, to a view model. And now we have this nice, simple way of ensuring that we're going to have a valid list of view models. We don't have to worry about the null checking. The mapping is all done conveniently for us. In string as well, I think there's a lot of nice stuff here. So very simple ones like is empty, is not empty, is null or empty, substring things. There's a whole list of functions there that I've barely broke into, but every time I need something, I tend to be able to find it. So again, something very simple, if the URL is not null or empty, load some data with it. Or again, assigning a title or some text to a view model per se, we could use or empty to ensure that we're not passing in null here, that we always have some valid string. So, kind of in summary, Kotlin functions, they're very simple, but as you start to dive in, they do a lot of stuff, and they actually have a lot of power to make our lives easier and to start to rethink and change how we start building our apps. So, if you want to talk to me further, you can come find me afterwards or pretty much online everywhere at N8 Ebel. Thank you for coming.